Hello students and welcome to this calculus video. In this video we're going to begin practicing solving for volumes of solids of revolution. So let's get started. So in this question here we have an area that is bounded by two curves. We have y equals x plus 2 and y equals x squared. And it's nice that we do have a little bit of a graph here. And so we're kind of going to use what we learned in our last video to find the volume of the solid form when the region is rotated about this x-axis. So we're rotating around that way. So keep in note that we are going from -1 to +2 over here. And so I'm going to set up my integral and we're going to find the volume, and we know that this is going to be equal to pi times the integral from -1 to 2. And then what is the that outer function? Well, that's y equals x plus 2. So I'm going to get x plus 2 minus 0. I'm not going to write the minus 0, but remember, if that rotation changed or if we went down to a certain point where we weren't rotating around the x-axis, then we would have minus something else here. So minus 0, I'm not going to write that. And then squared minus the inner function or the lower function, which is going to be x squared minus 0 again. And then this all gets squared dx. So what you do with this is you need to simplify it. Pretty much nothing has really changed, just the simplifying is super annoying. So we're going to get volume equals pi times the integral from -1 to 2. This is going to be x squared plus 4x plus 4 minus x to the 4th dx. And then we can find the antiderivative. So volume equals pi times the antiderivative. So then that's going to be x cubed over 3 plus 2x squared plus 4x minus x to the 5th over 5. And we're going to evaluate this from -1 to 2 using the second fundamental theorem of calculus. So this is the long part. Once you've actually taken the antiderivative, you know what you need to do, substitute in your values. This happens to be the long part. So let's go ahead, speed up the video, and actually just spend some time doing some arithmetic. All right, so that's going to be our final answer in this case. The volume is equal to 72 pi over 5. And keep in mind that what we're doing is we are rotating around this x-axis. That's why we're getting pi in this case. If we had units, keep in mind that they would be cubic units depending on what was given to us. So now in this next question, we're going to find the volume when the region is rotated about the line y equals to 4. All right, so y equals 4 is going to be right there. So that's where we're rotating around. And what you need to notice is that so they're rotating around this point, the outer function and the inner function changed. The outer function now has become y equals x squared, and the inner function has become this x plus 2. That's going to be the inner function. So that's what you're going to have to keep in mind when you're doing the outer minus the inner. Keep in mind though, we're also going to subtract the axis of rotation. So we're going to subtract 4 in both of these. So let's go ahead and write that out. So we're going to have volume equals pi. We're still going from -1 to 2. So my outer function first is going to be x squared, and then I have to subtract this axis. So -4, this all gets squared and then subtracted by the inner part, which is going to be x plus 2, and then we still subtract that axis, it all gets squared dx. So that's the setup that I want you to take note of. Nothing else has really changed about this process, still fundamental theorem of calculus. So let's go ahead and speed up the video and solve for this. So after all of those calculations, dealing with these fractions, my final answer comes out to be 108 over 5 pi. Again, whatever those units might be, it would be cubic units. And now we're going to move over here to this final problem, in which case we're taking the same exact region and we're going to be rotating around the line y equals -2. So we're going to have this line here, y equals -2, and we're rotating around that. That is our new axis. So what you want to know, again, is that what is the shape that is happening? What is being created? You know, is it kind of like a donut? Is it kind of like a bowl? So there are a lot of 3D visualizers that you can use so that you can actually see what these shapes turn out to be. But what you need to know here in this case is that we're going to have a big gap here, which is fine. But again, we're looking for the inner and the outer. So what is the inner and the outer part when in relation to the line y equals -2, where the outer function is here, this linear function, and then the inner function is our parabola. So now what we want to do is we want to take that into account. We're still going from -1 to 2. So notice here how bounds our integration are still where those are intersecting. So volume equals pi. We're going from -1 to +2. And we're still doing this, our outer minus the inner. So my outer function is going to be x plus 2 minus -2, so +2. This all gets squared, minus the inner part, which is going to be x squared minus -2, so that's going to be +2 squared dx. And again, this is going to be all about taking the time to simplify this, integrating, doing the antiderivative, and applying the fundamental theorem of calculus. So since those are already skills that you know from previous videos, then we're just going to speed up the video here, and I'll see you at the end. And our final volume for this final problem in this video is going to be 162 pi over 5. So keep in mind that yes, these problems have a lot of arithmetic. I get it, and you're going to get tired doing these problems. So what you need to keep in mind is that if these show up in a free response question, go search for those, whether that's in the calculator section or whether that's in the 4 non-calculator questions. And search for this volume specific question, knowing that it's going to take a while, and knock this out first. The free response section, you're going to be kind of tired at the end of your test time. So if you can knock this out first, because of how long some of these problems might take, you're going to be knowing that you're going to get the toughest, most annoying problem out of the way first, getting the points that you can, and moving on to the easier problems from there. So just test taking strategies coming up at the end here. Of course, if you notice a mistake or you feel like you're getting something else and you need some help with this, going over some of these problems, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.